Hello, in this video I'm going to be going over naming of molecules with polyatomic ions. So, you guys have this sheet, polyatomic ions. On most tests you'll have a periodic table, and on the back you'll have the polyatomic ion sheet. However, on a naming test you may not have the polyatomic ions, depending upon whether it's prep chemistry or standard chemistry. But here we have acetate, ammonium, carbonate. We have all these various names for these polyatomic ions, and it'll really help you to have them memorized, because then the rest of the course is going to be that much easier. Especially if you take IB chemistry, it'll be essential for you to just have that base knowledge of which polyatomic ion is called what. Alright, so we got phosphate is PO4, 3 minus, sulfate SO4, 2 minus. How do we do this? So, let's say we have Na2 SO4. We want to name this guy. So what we do is we write the name of the first element, sodium, and then we write the name of the next part, in this case, this polyatomic ion, sulfate. And we don't change the ending at all, we just write the name of the polyatomic ion. The name of this would be sodium sulfate. Doing another example, let's say we have KNO3. We write the name of the first element, potassium. And then we write the name of the second element. Usually we change the ending to IDE, but since it's a polyatomic ion, we just write the name of the polyatomic ion, nitrate. Potassium nitrate. So now let's flip it the other way. Let's do a couple of examples where we're given a name and we have to write the formula. Alright, so we have calcium phosphate. So we know calcium is Ca, and phosphate, when we look at our polyatomic ion chart, phosphate is right here, and the glare is in the way, but it's PO4 with a -3 charge. PO4 with a -3 charge. Remember, calcium is here in the second column, so it's a 2+ charge. So now we got to crisscross it. 3 goes here, and the 2 goes here, but that looks like 42. So we want to make sure that we're showing that we have 2 PO4s. So we have to put it in parentheses. Whenever you have more than one polyatomic ion, you put the polyatomic ion in parentheses. And we got Ca3PO4, 2 would be calcium phosphate. Doing another example, why don't we do potassium carbonate. So in this case, potassium we know is K. Carbonate, we look at our polyatomic ion chart and we know it's CO3 with a 2- charge. Or, better yet, we have it memorized and we know it's a CO3 with a 2- charge. And we know potassium, it's in column 1, so therefore it's +1. And we crisscross it, K2CO3 would be potassium carbonate. Alright, let's take it one step further, and why don't we add some transition metals in this, which would require the Roman numeral rule. So, thinking of an example real quick, let's see, I've got iron 3 sulfate. Iron 3 sulfate. So we want to write the molecular formula of this. Iron, and this Roman numeral is the positive charge of the transition metal, so it's 3+. Sulfate, we look at our polyatomic ion sheet and we find that it's SO4, and it's a 2- charge, and we have to crisscross to balance so that the overall charge is 0. So this 2 goes here, and this 3 goes here, but since we have more than one sulfate, we need to put in parentheses. So it's Fe2O3, iron 3 sulfate. Doing another example, let's do copper 2 chlorate. Copper 2 chlorate. We got Cu for copper, and it's a 2+ charge. Why? Because of the Roman numeral 2 is saying that this copper is 2+. chlorate, ClO3 with a 1 minus charge because we memorized it. And now you have to crisscross it to make sure the charges balance out to be 0. That's 1 there, that's 2. Since we have more than one chlorate, we put it in parentheses so it looks like we have 2 chlorates and not 32 oxygens. Alright, doing it the inverse, let's say we have FeOH2. We want to write the name of this guy. So we're going to write iron. And iron is a transition metal, so we need a Roman numeral. And OH is hydroxide, polyatomic ion. We know OH is a 1 minus charge, but there's 2 of them, so it's 2 minus. Therefore, this iron needs to be 2 plus to balance it out. And we show that 2 plus through this Roman numeral. Alright, one more example like this. We have TiNO3, but there's 2 of them. We need to write the name of this. Ti is titanium. Has a Roman numeral because it's a transition metal. Nitrate. Nitrate's a minus 1 charge, but there's 2 of them, so it's 2 minus. So again, this is 2 plus. And we write it as titanium 2 nitrate. Alright, there's one last thing that's slightly tricky, is what happens when you have those weird, not transition metals, but those weird polyatomic ions that are not found on the polyatomic ion sheet. Well, if you have all of the ions, polyatomic ions from the polyatomic ion sheet memorized, then it makes these more difficult polyatomic ions that much more manageable. So there may be some things like selenate or tellerate. So Se and Te are the base elements in those polyatomic ions. We know that sulfate is SO4 with a 2 minus. If we want to know what selenate is, since selenate is in the same column as sulfur, then it's going to look very much like sulfate. It's going to be SeO4, and it's going to have a 2 minus charge. Selenate, sulfate. The only difference is that first element, selenium versus sulfur. What do we have? Tellerate. Same deal. Tellurium is in the same column as sulfur, so it's going to follow the same pattern. We have TeO4 with a 2 minus charge. Looking at the halogens, we have fluorine, chlorine, bromine, iodine. On the polyatomic ion sheet, you have chlorate is ClO3 with a minus charge. You have chlorite with a ClO2 minus charge. You have hypochlorite, which is ClO with a minus charge, and you have perchlorate with a ClO4 minus charge. You have all those 4. What is going to happen when you have F in place of chlorine is you're going to have the same naming pattern. So if you have FO4 with a minus charge, that is perfluorate. If you have FO3 with a minus charge, that is fluorate. If you have FO2 with a minus charge, that's just like ClO2 with a minus charge, that's fluorite. And if you have FO with a minus charge, that is going to be hypochlorite. It follows a similar pattern. Same thing with iodine and bromine. If you had bromite, that would be the same as BrO2 minus or ClO2 minus, same as chlorite. If you had iodate, that would be iO3 minus. What if you had perbromate? That would be BrO4 minus. Or hypoiodite would be hypoiodite would be IO minus. So it follows a similar pattern. Another pattern that you want to take note of is ite is 1 less than 8. Ite is 1 less than 8. So we have nitrate minus 1 charge. Nitrate. So if we had nitrite, that would be NO2 minus. So we have 1 less oxygen than 8. So to be more specific, ite is 1 less oxygen than 8. So what if we had SO4 2 minus? That's sulfate. So what would sulfite be? It would be SO3 2 minus. How about chlorate? Chlorite, first of all, is ClO3 1 minus. Chlorite would be ClO 1 minus. And what happens if you took SO4 2 minus and it's sulfate, but you called it now persulfate? Technically, the pattern would be SO5 2 minus, just like the pattern that you have here. So essentially, the pattern that you really want to know is perchlorate ClO4, chlorate ClO3, chlorite ClO2, hypochlorite ClO. So basically, ite 1 less oxygen than 8, hypoite 2 less oxygens than 8, and per 8 is 1 more oxygen. But to make it a little more tricky, which is why memorization is really key in this, the 8 is sometimes with 3 oxygens and it's sometimes with 4. So looking at it, phosphate, ran out of room, phosphate is PO4 with a 3 minus charge. Sulfate is SO4 with a 2 minus. So those both have 4 oxygens. But then when you go to nitrate, it has 3 oxygens, or chlorate has 3 oxygens. So really, having these base polyatomic ions memorized is really going to be beneficial for you, not just for the naming test, but for the rest of the semester in chemistry, especially in IB chemistry. Because without those memorized, it makes it that much more difficult. You're going to be spending most of your time struggling over how to find which polyatomic ion is which, and you really don't want to be wasting time doing that. So that's naming with polyatomic ions. It's a lot. Really, it just takes practice to really get a firm grasp on it.